Hello everyone. Welcome to LeetCode, not LeetCode Live. I'm coming to you in a pre-recorded stream. So if you're watching this stream, I'm on vacation currently, having the time of my life, but I want to make sure that everyone has something to watch while I'm out. So here we are. We're going to continue on with these and we're going to do some medium questions. Today in my stream, I hit 300 questions in total, which is a nice milestone. So let's just continue on that trek and let's try and make it to 400. Our next big milestone. We have a long way to go, 2,422 questions, but we are making a lot of great progress. So today we're going to start off with this question that I have never seen before, but it seems to have some decent like to dislike ratio. It's called execution of all suffix instructions staying in a grid. So there's an n by n grid, so we're dealing with a square with the top left cell at 0, 0 and the bottom right cell at n minus 1, n minus 1. You are given the integer n and an integer array start position, where start position equals start row and start column. Indicates that a robot is initially at cell start row start column. Okay, everything's great so far. You're also given a 0 indexed string s of length m, where s of I is the ith instruction for the robot. Left move left, R move right, U move up, and D move down. The robot can begin executing from any ith instruction in S. It executes the instructions one by one towards the end of S, but it stops if either of these conditions is met. The next instruction will move the robot off the grid, and there are no more instructions left to execute. So return an array of length m, where answer I is the number of instructions the robot can execute if the robot begins executing from the ith instruction in S. So do they want me to return? Let me see. Okay, so n equals 3, start position is 0, 1. Okay, so how many places I can go if I start at R? So starting from start pos and beginning execution from the ith instruction, RR, only one instruction R can be executed before it moves off the grid. RDDLU, all 5 instructions can be executed while it stays in the grid. DDLU, all 4. So it doesn't seem, well, it doesn't seem like it's too bad. However, you know, what's my brute force method, right? My brute force method, I mean, in the worst case, we will have to do this how many times? We will have to, for each, we have a start position, we'll have to go through this however many times. If we start 1, 2, 3, 4, 5, 6. So it's almost like what? It'd be n squared, right? Or would it be n squared if we're starting? Well, how many do we, what if we do it actually the opposite way, where if we're at 0, 1, if we're at 0, 1 and we go 1 up, okay, we're already 1 off. So if I go to L, let me see, if I start at here, and if I'm at 0, 1, I can go 1 over here, plus, I guess, whatever the previous thing was. So that's 1. Over here, if I start down, 0, 1, I can go down. Well, I can go down, left, and up. So it's not really going to be, this is not really going to be dependent on the previous thing, because left is different than going down, left, up. So 1, 2, 3. So I'm almost thinking that, like, for each one of these, I'll just simulate it. I don't know if that's the best way of doing it, but it's a way of doing it. And I'm okay doing it like that for now. And then, you know, we'll just figure it out. So this is what we're going to do. I'm going to say const grid is equal to a new array of size n. We're going to fill this up with a new array of size n. And I guess it doesn't really matter what we fill it up with, but just so that they're not empty slots, like a sparse, just so that it's not a sparse array, we'll fill this up just with zeros. Let me go ahead and console log that real quick, just to make sure we have what we want. Okay, cool. So we have the starting position, okay, which is going to be, so let's do this. Let's do const start row, and actually let's do let start row is, or even better, we have S, right? Yeah, I think we should do, If I start at S and go all the way, okay, if I go to R and go all the way, see there's a little bit of a repeated work here, right? Because if I start, oh man, it kind of just messed up my neck real quick. If I start at R, only one instruction can be executed. It's like, how many more things? I almost feel like starting from here is nice, because then it's like, okay, I know how much I can start at R, right? If I just add another R, how many more can I get? But it's not really how many more, it's actually how many less. So again, it's gonna be brute force. I feel like we're doing repeated work, but let's just go for it, right? So let's do for const, maybe I'll say direction of S. I can say let start row, start column equal start position. Could do this. Then what do we want to do? Now I have two numbers, start row and start column. And I also have the size of my grid. I can just now simulate it. Yeah, I'm really not in love with that. I really do feel like we're just duplicating work again. I'm going to refactor this a little bit. Because I want to do for let start point equal 0. Start point is less than s dot length. Start point plus plus. I can get my start row and start column. That's start point. Now I just want to simulate everything from start point until the end. And do I even need to do that? For let's start point. Because we also need to do, I feel like start point is not really the best, but I can also say for let rest equals start point. Rest less than s dot length. The rest literally meaning the rest of the string. Rest plus plus. And let's also say let instructions equal 0. Const direction equals s of rest. So it's going to either move the robot off the grid. There are normal instructions left to execute. So it's pretty much, oh, I can just count all the way. Like if I make it to the end of this string, or rather if I make it to the end of here, I guess either I'm going to make it to the end or I'm just going to move off the grid and I'm just going to be, yeah, okay, I think I know what I can do here. I can do instructions plus or equals 1. And now we can just create like a big if else case, like upright. We're going to do upright, down, and left. Maybe I can do a switch here. Switch on direction. Maybe here I can say case U. Maybe that's not the best though. I can say if direction is equal to U and let's see, start row minus 1 is less than 0, then we'll just say break. If direction is equal to R and start column, oh, but then we actually have to, let me think about this. Oh, you know what? Maybe we can do this. I have an idea. Okay. If direction equals R and start column is what? Greater than, or maybe it's just equal or greater than n minus 1. And we'll break if direction equals down and start row is greater than n minus 1, we'll break. If direction is equal to left and start column is less than 0, or start column minus 1 is less than 0, we'll break. So let me think about this. What I'm doing here is maybe here I can do a switch in direction. I can create all my different cases. Let me just do this real quick. Case U. Here we'll say R, D, left. Okay, if it's up, then I'll say start row minus equals 1. If it's right, we'll say start column plus or equals 1. If it's down, we'll say start row plus or equals 1. And if it's left, we'll say start column minus equals 1. So let's go through this real quick. I just want to start off with this one. Okay, and we have our grid. So we're going to say start point is equal to 0 for this whole string. We have start row, which is 0. And column is equal to 1. Instructions equals to 0. And we have rest starting here. Okay, so the const direction is s of rest, which is r. So that means now we do start column plus or equals 1. Okay, remember n here is 3. So start column plus or equals 1. Oh, I shouldn't say, oh, actually, I guess that's fine. Start column is 1. Okay, that's fine. Okay, and then we have another r, and now we add 1 to instructions, right? Because if I do the direction here was r, so if it's r and start column is greater than n minus 1, so n is 3, n minus 1 is 2, start column is 2, which is not greater than 2, so that's fine. Then we get to the next thing. So the next thing in rest is another r. We increase this, and that is greater, so now instructions is just 1. So I think we can continue doing this because 1, 2, we'll add 1 here, we'll add 1 here, 2, 3, 4, 5. I think as long as I don't break, I'll keep adding instructions, and then at the end, what I want to do, let me see if I just remove all this now. Const grid, we can also have const output, and maybe right at the end here, we'll say output.push instructions. Now, this really does feel brute force. Even if it works, it doesn't feel right. And like we're seeing here, it's also wrong. So that's fine. I mean, we're gonna figure it out as we go along. So 152.100, it was going good up until that last one there. So why would that happen? So 1.5, we should be getting a 4. So now let's say start point is 0 for let rest equals start point. Okay, then start point is 1. Rest is also starting at start point, and then we get to 2. When we get to 2, our string is effectively this, DDLU. So start row and start column equals start position. So we'll get 0 and 1. Instructions are 0. Let's see. The answer we got here was what? We got a 2 when it should have been a 4. So if I go down, switch direction, D, so start row plus or equals 1. So let's get our row and our column. This started off at 0. This started off as 1. We're going to add 1 here. We're still in the confines of everything. So if direction is down and start row is greater than n minus 1, then we break, but that's not the case. So now we just add 1 to instructions. Equals 1. Then we get to the next D, right? Start point, rest plus plus, and we get to D here. s of rest. Okay, if it's D, again, start row equals 2. That's still good because it's not greater than n minus 1, so we add another one to instructions. Then we get to a left, which means the column is going to be 0. If I get left, start column minus equal 1, so it's 0. If it's left and start column, let me see, this is where I think I may have messed up. Why would this be, if direction is left and start column is less than 0? Similarly, if it's up and start row is less than 0, then break. Probably that's where I could have gotten a bug. Let's go ahead and comment all this out. Let's try this again. So 154310, okay. So that's good there. Let's try this next one. 41000000, okay. So none of them can move. So let's go ahead and submit this and see what we get. So, I mean, we got the answer, which is awesome. I can, like, for people that are watching, I definitely feel that because of the amount of easies I've done, and I think just general LeetCoding practice, I have become more comfortable with LeetCode. However, I will say that I don't feel like this is the most optimal way of doing this. I feel like maybe I'm doing duplicate work. Let me submit this one more time and see what we get. 60.90. Seems like maybe we did okay. And if we think about the time complexity, like our space complexity here is just going to be n by n, right? So just give me 1 second. Okay. Now our time complexity is like, it's actually, how many times are we iterating through this? We're iterating it, we're always iterating from the beginning. Like we're doing 5 first, or 1, 2, 3, 4, 5. We're going through 6 strings to 4 strings to, so I think it's like n factorial. I think that's what the time complexity of this is. Which, okay, now I'm so curious. Is it not? Is it n factorial? It's probably, there's got to be a better way. Oh, Python of mg versus brute force. There's backtracking, depth first search. Okay, I need to read this to learn about this. Okay, so, well, why is it even m squared? What is the brute force? Where m is the path. Okay, start v for I equals k, I less than size, and min. Push back. Okay, this is interesting. Okay, let's go here and read. So m is the length of the command. If we want the O of m squared solution, that is quite straightforward. An interviewer may not be satisfied, thus we need to do more. First, let us think. How do we know when will the robot move out of the boundary if the robot starts at the current step? We know the start position of robot. Say xy means x and or row x and column y. This is quite different from Cartesian coordinate. Please get used to it. Okay. If the robot move out of the boundary, one of the 4 situations must happen. Then let us trace back from the last command to the first command. We assume that if the robot operate all the commands to the end, whenever it starts, the final position is 0, 0. Notice that this is the virtual position, not the real, just for easy understanding. Suppose we have the command LURD at time t equals 4, the location will be 0, 0. If the robot starts at t equals 3 and the command will be D, what is the initial virtual position? -1, 0. In other words, at time 3, the position will be -1, 0. If the robot starts at t2 and the command will be RD, what is the initial virtual position? Okay, we can find each virtual position at time t when the final position without bound is 0, 0. We keep track of each initial vertical and horizontal position and record them in a separate dictionary. Then we can judge if we can walk on to the end. Okay, I'm confused. Can I read another one here? Execute if the robot, so solution 1, brute force. So x of y equals start for j in x range I through n of a. O of j if 0 is less than or equal to n and 0 less than or equal to y. Return map of test. Okay, this is for every start point O of m solution starting from the first order, find the difference on x-axis and y-axis. Count, record the position with start. I need to watch a video on this because this is confusing here. This is officially confusing. It's good, again, it's good that we solved it. I think that I may have even come up with a worse time complexity than the ones they show, unless I'm not just thinking about this the right way, because they're doing n squared. But will this be, I'm going through, well, I guess it is n squared, because they're starting from 0 and then going through everything from that point. Yeah, I guess that is n squared. I'm not sure why I came up with n factorial. This is one that I'd like to see a video on because the optimal solution here, I really don't understand. So let's see if we can go to another one. I'll put this one on my follow-up list. And I'll say like watch video. Some of the, I mean, it's hard for me to like read one of these things while recording a video and understand it. So instead of me trying to understand it while I'm recording the video, I'll do it on my own time. But really the video is just for you to see how I initially thought of it, and we'll, just continue doing questions. All right, so queries on a permutation with key. So just had a drink of water. If you guys have water, drink it. Oh wait, what did I do here? Okay. Given the array queries of positive integers between 1 and m, you have to process all queries I from I equals 0 to I equals queries.length minus 1 according to the following rules. In the beginning, you have the permutation p equals 1, 2, 3 all the way to m. For the current I, find the position of queries I in the permutation and then move this at the beginning of the permutation p. Notice that the position of queries I and p is the result for queries. Okay. 3, 1, 2, 1, m equals 5. The queries are processed as follows. For I equals 0, queries of I equals 3, p equals 1, 2, 3, 4, 5. Position of 3 and p is 2. Then okay. This just seems annoying. That seems very annoying. I think what I'm going to do, so I'm not gonna I don't want to make excuses, but we all know that we're all human and some days are better than others. And today I'm just a little bit I don't want to say stressed out, but it's been a little bit of a day at work. So I think I'm gonna just wrap it up for today, just on that one question. Again, I feel good that we at least went through it. We solved it. It goes to show that just some planning and some drawing at least will get us most of the way there. We missed on one of the complexities. I know that maybe this video is not exactly what you maybe wanted to see, but it's okay. We're human. And if anything, I just want to at least help some of you all out there and show you that, the grind is not easy and some days are better than others. And frankly, today I'm just a little bit overloaded with LeetCode and work in general. So I want to take a little bit of a early end here. So with that being said, thank you for tuning in for today's pre-recorded stream. I'll see you all again tomorrow for another stream where we will continue doing more questions. So I hope you all have a great rest of your day and happy coding. Later.